Ladies and gentlemen, welcome back to our online summit here at Pepperl+Fuchs. You've just arrived at the networking lounge. Now it's time to get more into detail and discuss our topic of the day. It's Ethernet-APL. And literally, it's a broad field to discuss. And of course, we would like to ask you, what are your questions and maybe what are your inputs for us? Use our live chat button and ask your questions, or tell us where maybe you would like to have the Ethernet-APL used. So we'll discuss that on stage with our podium here. Let me welcome Lutz Liebers, Michael Kessler, Gerd Niedermeyer, and Gunther Rogol. Maybe we just go around, give us a short introduction of yourself.
Yeah, good morning. My name is Lutz Liebers. I'm the president of the Process Automation Division within Pepperl+Fuchs. I'm more than 30 years with Pepperl+Fuchs. I have an engineering background and I'm proud to be here.
Thanks. Michael.
I'm Michael Kessler. I'm with PNF a little bit longer than Lutz. Sorry. And I'm responsible for the business unit Components and Technology in our Process Automation Division, and as such I'm responsible for our interface technology, infrastructure technology portfolio, and part of that is APL, and that's what we talk today.
Thanks a lot. Gerd.
Yes, hello everybody, my name is Gerd Niedermeyer. I'm from BASF company just across the river here, and yes, thank you for invite me for this summit from Pepperl+Fuchs. And I'm until 32 years with BASF in large capital projects, and we are working closely worldwide on several projects in BASF, and I'm a senior automation manager, and I'm happy to tell you something about our story, what we are going forward with Ethernet-APL.
We're happy having you, Gunther.
Okay. Welcome everybody, my name is Gunther Rogol. I'm with PNF now for 31 years in various positions. And the last 20 years are basically, I was involved in growing up the field bus activity within PNF. And the past 5 years I take dedicatedly care about APL. APL here in-house with Pepperl+Fuchs, but also within the APL activity, managing the technical activities for APL.
Thanks, gentlemen. So at least 30 years each in the company.
Looks like I'm the chicken here.
Well, yeah, it's a lot of experience, and it's great having you. So there are already questions in our chat, but first maybe let's talk a little about the motivation, Gerd, since you're one of the users for Ethernet-APL. Tell us about the benefits.
How many time do you have?
As much as you like.
Okay, so let's get started. It's a long story behind, and I want to compromise a little bit, yes. And yes, we started with digitalization 15 years ago with Pepperl+PA and with Emerson Field Bus Foundation. And over 3 years ago, we had a congress about our NAMUR association, and there I heard the possibility to be able to go with Ethernet in the field. And on my background, I thought it's the best choice to go with Ethernet to the field. And the other question for us was, yes, Ethernet to the field, but that is not everything. We want to go with one technology to all components in our automation structure. So we want to go with Ethernet to the motor control center, to the VFDs, to the frequency drivers, to the sensors, to the actors. and so on. And then we talked over the last 2 and 3 years to some companies which we are related to, and we started to have then the possibility to have a test lab in our plant in Ludwigshafen, and then we tested the communication availability with different DCS systems. We had a lot of DCS systems installed and tested the communication via prototypes of APL sensors, actors, and also field switches from Pepperl+Fuchs and other companies. And the result was very good. And so we want to go forward with this technology when it's available next year or something. And then we want to go with this technology to improve our visibility of the plant to the asset management station, to the cloud, to go directly to the sensors. And it's a quite good story behind, and this is what BASF is looking for, because in our company strategy is the keyword is digitalization. And I think this is a keyword for everybody who is working since Industry 4.0 is starting up the last years, and everybody's looking for digitalization. And we think that Ethernet, and especially APL, which gives us the chance to go to the X zone with Ethernet in 2-wire application zone. That's also a very important topic. And this is very good for us to go entirely, as I said, to all field devices, to all components with Ethernet technology, high-speed Ethernet communication to all devices, and get connected to all data which are available in the plant. So it's a very good thing, and we think this is the technology which we have to use for our next project in BASF.
Thanks, Gerd. So now we got a nice picture of what the use is for you. But maybe let's have a look from the supplier side on APL.
Yeah, actually the motivation from us was really coming from our customers like BASF, talking us about the digital communication, the limitation that the current technology does have, and especially on their journey on the digital transformation and usage of new technologies or applications, there are some limitation in the existing technology. So that's why that was the motivation for us to go ahead with Ethernet-APL. And also that we are of the opinion that Ethernet-APL is really an enabler for Industry 4.0. It is a necessary step forward in the process automation.
Mm. And not only that, since Pepperl+Fuchs is really investing in this new technology.
Yeah, that's actually in our genes. I mean, we are, for more than 75 years, we are innovators and inventors of new technologies. So starting with the proximity switch and over interface technologies, over remote I/O, over digital communication, we were always the pioneers of new technologies, and therefore the development of Ethernet-APL is a normal step for us. It is a quite usual step forward in our technology-driven company. We are of the opinion that in the future all field devices will be IP-based. As Gerd said, they want to go into communication into the field device using some other application that are not existing today with the limitation in bandwidth, and therefore we think that it is absolutely necessary to develop. Mm. In addition, for sure, we are market leader, as I said, and therefore we have to defend our position in the market as well, so therefore we have to go with the new technology. So that's why, so Michael, you want to add something from the technology?
Yeah, first, I want to add one invention that's always forgotten. PNF is also the inventor of the isolated intrinsic safety barrier. So actually it was invented before PNF invented the proximity switch. And as such, that was the very first interface in process industries. And moving from there to field bus to remote I/Os, and it's the very logical step to also invest heavily in Ethernet technology for field instruments. And as Lutz said, our clear vision is that all instrument will be IP based, and Gerd has put it in the right word. The very important factor in that is that actually this will end up in one communication architecture for everything.
Yes.
And in other applications, we are already seeing that in office automation, in, as they call it, IT. That's state of the art. Nobody connects a printer via USB today. It's all Ethernet. At home, you're doing the same thing. And in process industries, we're a little bit behind because we don't have the physics to do that. And that's why we have started very early to invest in that. The very first meeting on that was in 2011, when some companies talked about if that may be a good idea. And from the very beginning,
P&O discussion panel?
Excuse me?
Was it P&O discussion panel then?
No. Actually, it was a meeting that was at the same time as Hanover Fair, because we all have been there. At that time, we still had physical fairs, and it was actually a meeting that was dedicated actually to that discussion and asking the question to the participants: are you interested? Is that something we should work on? And we at P&F, we identified that as a big chance and as a big challenge, and started to invest heavily in that. And maybe Gunther can tell a little bit more about the technical developments we did during that time. So we had pretty early also working demonstrators for that.
Yeah, so it's 9 years of development. Gunther?
Yes, I think the key point for P&F was basically that the step from existing to wire digital communication to Ethernet-APL was not so far, basically, because we are dealing with this technology now for 20 years. So we have a lot of experience, market experience, application experience, gained together with our customers. So we exactly know what goes in the right way and what goes in the wrong way. And that was our intention, basically, to transfer this experience to the new physical layer based on Ethernet communication. And so I think P&F was in the best position to develop, to make the first steps, and to basically also design the boundaries of the new technology.
All right. We'll get more into detail then. Maybe just excuse us for jumping a little because, as I said, we already have a question. So I would like to have our audience integrated here. So let me just hand over the first question from our chat. There is a migration path for Profibus PA field devices implemented in the field switch. Are there any plans to implement a similar migration option for foundation field bus devices?
Plans mean that we have a solution available? No, we don't have a solution, because just basically there needs some standardization work behind. So you can't just map information from foundation field bus device to any higher layer application protocol. This is not possible. So there's the need to standardize first. And then, of course, the infrastructure itself is able to convert this, yes. Technically, it's possible. But again, I think there is some standardization work required.
But it's definitely part of our target and our future. That we think that to complete the migration of existing digital communication needs to have also this integration of foundation field bus products into the Ethernet-APL structure.
Hopefully,
yeah. Maybe some additions to also to clarify a little bit the difference and why we have that for Profibus and not for foundation field bus. Then Profibus may have kind of a historical advantage, because Profibus PA was from the very beginning some protocol that shared the protocol and the data structures and so on with a higher level protocol that used to be Profibus DP. And with the evaluation to evolution to Profinet, this interface was kept. So there is a clear structure and there are clear rules, standardized rules, how to convert the data of a Profibus PA device to Profinet. And there is no such standardized way to do that, and no such standardization for foundation field bus, and that's what Gunther is referring to, what we need to work on before we really can implement it.
Right. Hopefully question is answered so far. Now let's get back to maybe a lower level and talking about benefits. Why Ethernet-APL compared to existing technologies?
Existing technologies, yes, we have different technologies. I don't know, mentioned for the 20 milliamps. We have as we said, the field bus technology, Profibus PA, field bus foundation. And now we are looking for the next step, I will say, for Ethernet, yes. Why we are looking for Ethernet, why this is good? Because we are saying we have a higher bandwidth. We have, when you compare to field bus, we have 31.25 kilobits per second. And here we are talking about 10 megabits, so it's multiplied by 300. So we have different kinds of possibilities, yes, to go more in detail with the sensor. So we started with Profibus PA and field bus foundation, and with the higher bandwidth, what we get with the 300 times more bandwidth, yes. So we have more possibilities to get the data out of the sensors, out of the field devices and the actors, yes, and also from the MCC and VFDs, and so it's really the next step for us. The other thing is that we can go directly from asset management station to the sensor, and from the asset management station to the cloud, I will say, yes, and make some calculations and correlations in the cloud to see if there is a upset condition with these sensors, or there is something going wrong, that we can go to predictive maintenance. So this is also a very important step, that we can go for predictive maintenance. As you know, if something is failed currently, then you have a problem in the plant, and this we want to avoid. To have predictive maintenance available and installed. And yes, also the other thing is for plant optimization. We can go for plant optimization with the live data from the sensors, from the actors and all devices. Yes, and as I said, we can go for correlation for that and optimize the plant in a better way. So it achieves a lot of new possibilities where we are going on, and the other technologies are also something, but also another thing is the easy structure, as you have seen in the last session with Andreas. You have seen that the structure is very simple, and the structure itself is also high available, and this is also very important thing for us for a 24/7 running plant. It's very important that we have a high available structure, and this is also something what we are looking for. And here we can say we can install it in also 24/7 running plants in BASF as a stable technology and a robust technology to run these plants and optimize the plant by the higher speed of communication.
So, as a layperson said, it's way more than simply just a new field bus.
Definitely, yes. Definitely. I think the first, that is a twofold view on this. The first is the physical layer itself. There are major differences between what two-wire process field buses today offer to Ethernet-APL, and the major one is basically that existing field buses are really buses. So you have several devices connected to one segment, and Ethernet-APL is basically a point-to-point connection. So the vulnerability against faults is really reduced. So if you make, for example, a short, then it's only one device affected on Ethernet-APL, whilst on field bus there may be 4 to 8, which are not available anymore. The most obvious one, what Gerd already mentioned, is the speed. So we have approximately 300 times more bandwidth with Ethernet-APL, which offers a wide of new use cases which are not possible today. one obvious example is, for example, if you want to with existing technology, you want to upload or download parameters in a device. It might take 30 minutes for complex devices with existing field buses, or 420 hard.
So some users may hate it because they don't have time to have their coffee breaks.
Yeah, that thing, yeah, or to chat. Yeah. So this is just 2, 3, 4, 5 seconds, and then the download is achieved. So that will optimize a lot of use cases today, which are time-consuming, very expensive. The second thing you have to see is that, in meanwhile, also the application protocols make a lot of advancement. So there are use cases which have been very, very difficult to apply with standard field buses, like, for example, device exchanges. Very time-consuming. In most of the cases, you have to stop your control system. This is the parse. So also on the application protocol, there have been some advantages or advances like device exchange or communication in a run. So if you change your configuration in a running plant, you don't have to switch off your control anymore. You can just do it. So Fieldbus has a negative connotation today, but I see today that especially on the application side, there have been some advantages or advancements today.
Yes, and sorry, and also I will say what we just not mentioned, but heard also from Andreas' session before. We want to have one structure. We have an easy structure here with this new technology. Yes, we have a high available structure, and we can also we are looking just forward to use this structure also for safety applications. Yes, so this is very important for us. I'm an engineering guy. Yes, so and I'm saying why we are doing now with Fieldbus. With the field bus, we are doing field bus with 31 kilobits, and then we have the safety application in 40 to 20 milliamps. There's a technology break and has some disadvantages at the end. And so we are also looking together with our partners on a white paper, on a solution, how we can implement this also on the safety side, to have the black channel concept, what just mentioned before in the session, yes, and use it also for safety applications, and also have some diagnostic data then for safety applications, yes, to have the access directly to the sensor. So this is also something very important for us, that we have the same structure for everything, yes, for everything. It's not interesting for me. We have sensors, we have actors, we have safety devices, we have VFDs, we have MCCs, and all this kind of stuff. But they are all connected with the same physical structure, yes. And this is very important for us, and this is something what we reach out now with APL to go also to the sensors in the X zone, because this was the handicap before. We talked maybe 15 years ago about Ethernet applications, and we also always said, I was in a session maybe 15 years ago in a fair, and they said, we will use Ethernet. I said, yes, we can use Ethernet, but do we have an X zone application for Ethernet? No, we don't have that. I said, we cannot use it, yes, because we need for chemical plants X zone using of the Ethernet. And so now with APL it's possible, and I will say this is the right way to go forward with this technology also in our chemical plants. This was the last step to go full equipped on Ethernet technology based on all automation features what we have in the plant.
Before you go on, I've got to make one correction.
Just go ahead.
To your statement
I can lean back.
that the alarm bells have been ringing. You said APL is not just another field bus, and the clear statement, it's not another field bus at all. APL is not a field bus, it's a physical layer. It opens up communication, Ethernet-based communication to all existing buses, communication protocols, whatever you've got today on Ethernet. And like one example that may make sense in the field instrument with APL, an instrument can send an email with known protocols, with no new invention or whatever, it can, that's my nonsense example for that, it could also play Netflix videos or whatever. So it opens up communication for anything that's existing, and it's not a new field bus. It's only new physics to existing infrastructure, to existing ecosystems. Very important.
Yeah. Let's see, we're nodding very agile. Before I hand over to my to the next question from the chat.
Yeah, the main part, and Gerd mentioned this a little bit. If you look at the cost of a plant today, we are talking about the so-called OPEX and CAPEX. And the OPEX are the original, the cost that is coming through the plant life cycle. And especially in the process automation, and Gerd, correct me if I'm wrong, but we're talking about 30 years, 35 years, maybe 40 years. And therefore, it is absolutely necessary when you want to reduce your OPEX that you have to turn from a condition-based monitoring toward predictive maintenance. And therefore, the only way to do this, especially in an hazardous area application in the next zone, is really to use Ethernet-APL. With the existing technology, that is not possible.
With the performed maintenance, you might have the coffee breaks back then.
There's one reason I think it's worth to mention is that I explained before that standard field bus is a bus, so we have multiple devices connected to one segment. That means also that these devices share the power which is fed into the segment. That means that the power available for an individual device is very limited. Just to the fact that the power is limited because it could be dangerous in hazardous area, could ignite, could follow to ignition of environmental gas. So Ethernet-APL basically is a point-to-point. That means that the power available for one device is much, much higher compared to standard field bus. And more power means automatically also more functionality. And again, this is then the link to a Lutz statement, predictive maintenance, means that you have to equip your field device with additional electronic, with additional software. And this is only possible if you have more power. So this is a very, very, very big, important difference also to field bus.
Right. Let's just have a look at our chat. There are questions coming in. I just go through the lines. How will BASF handle on-off valves and level switches in their application? Will they be connected to the APL network infrastructure?
Yes and no. Yes, we have some, the installation looks like when we have the field switch in the field. We have a cabinet. It's not a big cabinet, yes, it's very handle, by the way. And we will just incorporate a small remote I/O, yes, a small remote I/O or a small remote I/O, because the remote I/O is also, and we are going, this is something what we are choosing because of robust technology and about our infrastructure, what we are choosing. We are going with Profinet here, and you will get many devices, I will say, which can be connected to Profinet. So, and then we install in this cabinet a small remote I/O if needed. This is one topic, so we can connect discrete devices on this remote I/O. This remote I/O is just connected daisy chain with the field switches. It's an easy technology. The other thing is valves, on-off valves. We are looking for valve islands. Valve islands, there are some customers, you know, I don't want to mention them right now, but you know, Festo, Biergard, Emerson and so on. But anyhow, yes. And they are also have the technology to go directly with Profinet, yes, and we can also install a small remote, a small valve island in this cabinet, and then we can also connect valves directly with these valve islands. So we tested everything, and this is also one thing, I think I didn't mention it before, because we have a test lab installed. We started with this test lab with a lot of companies who are sending us prototypes and all other kind of stuff. We started this in 2019, and we tested that, and it works out very well. And with Profinet, I'm not a Profinet guy, sorry to say, but we tested it with Profinet because Profinet has a lot of redundancy mechanism installed, and it worked out very well and is fast to be connected, and you can connect directly also on off valves. You can connect discrete signals, but normally we don't have that much discrete signals because we normally use transmitters and not discrete limits. But if needed, we can install a small remote I/O in this loop, and so you can just daisy chain the Profinet ring to the remote I/O or to a valve island if needed and where needed. Yes.
Thanks, Jan. Anything to add?
Yeah, I think that, I mean, you have to consider that we are right now in the beginning of the development of Ethernet-APL. So there is a handful of companies are working in this project, and a handful of products are being or will be available soon. We can also think of an APL I/O box to connect these valves or switches. So I remember 25 years back when we started with remote I/O, we were talking about so-called garbage collectors. So signals that are not usual, or they are usual in the plant, but not really connected to a digital communication. So therefore, this kind of technology will develop in the future, for sure. And we have to have a solution for all signals that are in a plant which are using Ethernet-APL. And there will be a lot of signals that are, let's say, not an usual standard signal that you can connect directly via Ethernet-APL.
But I want to say it's very easy to connect available devices or available technologies, remote I/O, valve island. It works very well. It's easy to connect. It's easy to handle. Don't be afraid. When you check it, it's easy to go. This was the result of our test lab end of last year, and it's really not a problem. It works very well because it's already installed in automotive industries, yes, and so you know in automotive industries they're working many years with Profinet. I don't want to move now to a Profinet session, but they are working many years about Profinet, and they have a lot of enhancements, and so we are quite good on this technology, and I can say it works very well.
User speaking.
But I think just one thing to add. I think it does make sense to think about also implementing discrete devices into APL, because we're talking about, have been talking about predictive maintenance. Also, discrete on-off valves suffer over the time through the hazardous areas they are used in. So, and in some application, they're really valuable on-off valves. So it might be that you add additional functionality, for example, to detect friction. So that means it takes too long to open a valve or too long to close a valve. These are all sign signatures which you can use to make predictive maintenance with on-off valves. And this is not falsely today available with remote I/O based discrete inputs/outputs.
Right. Let me just ask the next question from our chat. Feel free to answer. It's from Germany. What are the thoughts about APL being the highway into the cloud? Even if you don't use the remote accessibility of cloud technology, the tool environment will be without limits, especially if you think about AI for plant optimization and predictive maintenance.
May I?
Go ahead.
Yeah, simple answer, yes, APL is the enabling technology to do that. It's very simple. If you look at today's communication, in my keynote I had that one slide with the power outlet and the data acquisition project. Today it's actually a nightmare to get hold of the data, because it's hidden somewhere, it's using different protocols, there are barriers to get access to the data. And APL is the enabling technology to get a flat communication architecture in regards of protocols. And part of our clear vision is every field device will have an OPC UA server built in. OPC UA is the enabling technology to get data into maintenance and optimization systems. Namur has chosen that technology for very good reasons. It's open, it's standardized, and today there is also already standardized a so-called PADIM, Process Automation Device Information Model, that was specified by the Fieldcom group and was now also adopted by Namur and will be further developed in the future by different organizations. So there's a consensus how an instrument looks like on an OPC UA server. And that means the instruments will bring their own, not bring your own device, but bring your own information model. That means you don't need device descriptions or DTMs or whatsoever to understand what the instrument is exposing. And therefore, this gonna be the enabling technology to get data from everywhere, from any kind of instrument or device like drives or whatever, and everything you have mentioned, to the cloud. And that's very important because you don't want islands. At the end, you want to optimize your plant, not a single instrument. So what you really need is data from every aspect that you have in the plant. Mm-hmm. And also one thing, I have seen many demonstrations about Industry 4.0 where people generated and showed a dashboard of an instrument in the cloud. That's not what we really need at the end of the day, because we have that with the DTM or with device descriptions and so on. We can have that today. What we really need is an overview on the plant and to look at data of different data points, the interaction of the data, the correlation of the data to do real optimization. And that's where we need to go.
Mm-hmm. Sounds to me like that enterprises have to adapt a little, and that IT departments and automation departments have to melt together a little, or even way more.
Only a little.
A little more.
Yeah, I think yes. There's some drawbacks, of course, because maintenance engineer on the field level today, they don't know about Ethernet, other than they are dealing with Ethernet home. But in a process plant, this looks a little bit different. And talking about these interconnected networks, this has also some drawbacks. Think about cybersecurity. This is something which is a subject, let's say, which has been very visible in the last 10 years. And only on the levels where Ethernet has been used up to now, so on the system level, interconnecting networks, but not on the field level. So cybersecurity is something which has to be applied also for Ethernet-APL, which is not, okay, maybe others have a different view, it's not a big thing, because Ethernet-APL is based, again, on Ethernet, so it's just a physical layer. So all the rules and implementation which exist today for cybersecurity could also be applied for Ethernet-APL. And I think this is a big advantage.
Before I hand on to the next question, maybe it's a very important point, IT security, even from the user's point of view.
Yes, it's very important because of that. We go for isolation of each network, so it's as I mentioned before, also the safety network is isolated from the outside, and also the DCS network is isolated. And so we isolate everything. We have firewalls between, and we have an automation security concept, yes, applied in our company, yes, where we are looking, and we have automation officers which are looking on that. And yes, it's a very important topic, of course, and yes, we are looking on that, but I think it's handleable because we have in our plants we have some access controls. We have not everybody can come in, and so it's not so easy. It's not an open cyber room like you have it at home that everybody can connect you. Yes, so it's very isolated and very hard to go in, and it's not possible anyhow this way. And yes, it's important, of course, but I think we cover that.
Yeah. I think this is the so-called defense depth process. So each network access point is secured, and this also will apply in the future for APL, Ethernet-APL field devices, of course. So we have to ensure that these devices are designed according to international standards, hardening the devices themselves, and to avoid any intentional or unintentional access to the network through the field devices or the network infrastructure. So this is something we already apply into our R&D procedures, that we look through threat analysis into the products and identifying these kind of interfaces which may impact the security of the network.
But it also requires a certain behavior of the people working in this plant, because the majority of the risk is coming from the inside, not from the outside. So people are using USB sticks with whatever virus and putting these on the system. So therefore, that is a methodology you have to implement. And it's not only to protect from the outside to the inside or be a little bit faster than any hacker. It is really that you have to have a concept, and you have to really treat your entire personal people to understand why is it necessary. It's not just the methodology, it's really also changing in the brains.
I also want to add one thought. In today's plant, you've got to worry about Ethernet security anyway, because it's there. That's nothing new. From a certain level on, you've got Ethernet, and you've got to worry about security. And if you look at some recent hacker attacks, you can't feel safe with the field networks that you've got today with Profibus, DP, or even HART. There have been, since it's not glamorous anymore to hack anything in the general public, people start to feel proud if they have hacked field devices with HART and so on. So we had cases where these had been really hacked, and where it has been demonstrated that you can introduce into these devices and create damage. And from my point of view, if you have a flat architecture that goes throughout your plant, you've got to worry only about one security issue, and it's one you've got to worry about anyway, that's Ethernet. And you get rid of worrying about HART, Profibus, Foundation, Fieldbus, whatever, all the other networks that are in place. And HART is always there, no matter if you use it or not. All instruments people are using today have HART, and therefore are susceptible against attacks in any kind. And that, I think, it makes it at the end of the day easier to handle. To have one architecture, one physics, one protocol.
Anything to add? So let's just jump into the next question. This is more specific about the way it's built. Which cable are required for trunk and spur? Are they already available?
Yeah, the major goal when we started this activity, this APL activity, was to reuse existing fieldbus cable. So even if existing fieldbus cable applied now then more than 20 years in the industry, having a wide range of cable specification, temperature range, impact through chemical coming out of the plants, of the process, we thought that it would be a good start to have these cable to be usable with Ethernet-APL, and we achieved this goal, even if these cables are not really designed for this high bandwidth 10 megabits, but for 31 kilobaud. But yes, we can use them. But even in meanwhile, we see already cable manufacturers producing new cables, specific APL cable, which have again some benefits upon the existing fieldbus cable. So they're lighter, not too heavy, less expensive. So there's also a path forward for support of new cable, which again benefits then from the customer side, because they are less expensive and less drawback during installation.
Jumping to the point, availability, when can suppliers get started with Ethernet-APL?
The main goal is basically that we show the first products next year during AKIMA. That's the goal for PNF, but also for a lot of other APL companies. It does not help that infrastructure products are available, but you don't have any devices, field devices to connect to. So that's the reason this is a common decision and a common view of the APL member group, that during AKIMA next year we will show the first ready products for sale and for use.
And the answer for you to your question is, your question was when can they start? A year ago. So very simple. And it's actually we are working in the APL project. That's a number of 12 vendors that are really heavily investing in APL or Ethernet-APL, and they are, I hope many of them, we know about a number, are really working on instruments, on infrastructure, on solutions for Ethernet-APL. There are first prototypes of physical layer of PHY chips from vendors, so that's already going on. The data sheets are available of those chips, so it's time to start. If somebody wants to start really now, it would be a good idea to join the project, because there we have a very open communication. People are involved in finishing the standards, and that also helps to bring people, to bring designers up to speed. So that would be a very good idea. Latest by mid of next year, everything will be open standards. So anybody can download the specs, can buy chips, and can develop products. So there is nothing that's hidden or closed or protected or whatever.
Can you,
According, to my information, what I have, yes, we have this test lab, and we have a lot of components from different vendors. Just now it's really prototypes on communication way, but it's talking Ethernet, and we'll get final products, as Michael just said, mid of next year, and I will say something around 2022 should be feasible, yes, to start with, or with installations could be feasible, I would say, yes, to start with installations. But when you're looking for engineering process, you have to start early in advance. And we are looking also, I'm an engineering guy, as I said, we are looking in advance to start with such applications then up to 2022. That's our goal. I hope it fits, and the information I have is in this direction.
And to add, it is very important also to look into what kind of infrastructure I'm going to implement in my upcoming plant. So therefore, you ask when customers, end users should start now, and we would like to invite them to discuss with us how such an infrastructure could look like in the future. Because if you're going to invest in a plant, you're not buying the hardware first and then you look what I'm doing with the hardware and where do I connect it. The first is you have to have an understanding of your chemical process, but also of the infrastructure and how the plant is going to look like, and then we can help for the infrastructural engineering part, and that's why we would like to invite whoever's interested and come to us or make the contact.
maybe you can give us a little more insight about that communication collaboration of the companies.
Yes, maybe I can answer this. Yes, we have. I don't want to mention everybody, but all of our BASF vendors, nearly all, yes, send us some prototypes in our test lab. The test lab, maybe we have around 100 devices from different companies, and we have 5 DCSs from different companies, and so we are looking to connect them. And it's, yes, I will say it's a win-win situation between all these vendors, and the vendors say, yes, we heard about you have a test lab, can we test our device? Can we test our DCS with this new technology? We said, yes, come over, we will test it. And we test that all and give them some feedback, of course, yes, and they are very happy to have this feedback from us, and they are going forward to go for development. Why we are doing that, I will say, as I said, we started in 2019 with that test lab, and we want to bring out in this new technology our experience, and just what Gunther just said about the cable type. Yes, we said we don't want to have a new cable type, we want to have the same cable type as Profibus PA or Fieldbus Foundation. So these are some aspects, and other aspects comes up, yes. Also the redundancy aspect and so all this kind of stuff. We brought in this new technology in this test lab, and yes, it's a test lab where all these vendors which are bring some prototypes to us, coming in, and we are testing, and we have a good feedback and a good collaboration with everybody of these vendors. It's a lot of vendors and very well-known vendors. Yes, I don't want to mention each name, but you can believe that we have relevant vendors on our portfolio.
I have mentioned before that meeting, this historical meeting in 2011. That was basically the kick-off of what we are calling APL project today. We have been working for quite a while on requirements, specifications, proof of concepts, and maybe Gunther can tell a little bit about the challenges we had when we developed the P&F proof of concept. And then at the end, we came to the conclusion, we know what we want and we know what direction we want to go. And then the big question was, how do we organize ourselves? The first idea was start up a new foundation or organization. And then we came to the conclusion, and that was, I think that was a great move. Some people suggested, don't start up a new organization, make use of the existing organizations. And we approached the Profibus International Fieldcom Group and ODVA at that time if they would be interested. And the result was yes, and we now have a project that's hosted by these three organizations, and that was in regards of APL the end of the Fieldbus war. Maybe some of our spectators here know that and remember that, where the organizations have been fighting each other, and we managed that this is now one concept that's supported by everybody. And when you look at the, we had on ACHEMA 2018, we had the very first demonstration of that. You maybe have seen Andreas' presentation earlier today. He had a name tag on that show with the logos of all three organizations. That was a revolution that has never happened before. And that was really very helpful to make this an open, standardized, unique thing that helps to spread it through the world. Maybe Gunther, you can step in a bit on technology.
The biggest threat was for the group of companies was to start an IEEE project, standardize basically APL within the Ethernet basket of standards, because that was the clear goal. APL shall be compatible to Ethernet communication. So if you think about what does it mean IEEE, these guys, they are focused on dedicated application, not automation basically, but office application, bandwidth up to 40 gig coppered or fiber. So coming as a company or as an organization to wanting 10 megabit per second, that was initially not really understood. What they do want from us? This is something what was abnormal. But with the time, we explained them why 10 megabit would be the limit, because if your power budget you have available due to the limitation of intra-city safety is already as high as the energy standard Ethernet is putting into the signal, then no energy is left for the device itself. And this is something we had to make them understood. And a colleague of mine, Steffen Graber, a very smart guy, took the lead here for the APL companies, representing APL in this standardization organization, and it took him a lot of effort to make them understand what does it really mean. On the other hand, intrinsically safety means also that we have to care about how this intrinsically safety is applied for our customers. So how they have to verify an intrinsically safe loop. And very early with this initiative, we came to the conclusion it could be only something which is similar like FISCO, Field Bus Intrinsically Safe concept, which simplifies basically the verification of interconnection between a source and a field device. So also on this side, we had some standardization activities which are still ongoing. Goal is to have a finalized standard by end of this year. But here we have had a similar problem. We have to make understand hazardous area standard engineers, what does it mean to have high bandwidth communication? They're dealing with hard 1200 board or with a field bus 31 kilobaud. So this has also some impact on their way to think about hazardous area intrinsically safety. So also on this side, we had some educational work to do. But finally, we achieved our goal, and I think it was an interesting time, and everybody learned a lot out of this activity.
That sounds to me like we're not looking for a sports car, we're looking for a rally truck, which comes everywhere.
Which serves its purpose, yes. And if everybody is always using a racing car, and now he has to convert back to a tractor, then you can imagine that there's a lot of withstand, yes.
I like the rally truck more than the tractor.
That's good. Well, it depends.
But anyhow, I mean, if you look at the many companies that are in this Ethernet-APL project right now, we would like to invite even all suppliers to join us. Could be also engineering companies, system integrators, or end users are really invited to join. And if there's any interest, then let us know. We will make the contact, because as more as also end users are using this technology, as faster it will be implemented in the process automation industry.
Yeah, the more companies, the more winners, so to say.
Yeah.
Let me hand over one more question from our chat. Which configuration needs to be done to integrate a device into a network from out of the shelf up to assigned tag number? Which tools are used?
Yeah, it's easy to connect. Yes, you can. You just have to give them the tag number or no tag number. I will say 000. You can connect, and then you can install it in your DCS. It's easy to connect. Yes. Then you can give them the tag number, the IP address. Yes. It's very easy to do this in the DCS and also in the asset management station. You can upload then a asset management station. Normally we try to have a FDI package on the device. Yes, you can upload this FDI package from the device directly, so you don't have to search in the intranet for DD or DTM or something like that. So you can just upload this and can install it directly in your asset management station and can talk to this device. So it's easy to handle, it's easy to configure it, yes. This is something what we are also testing. And when you see one special option here is when you replace a device, yes, you connect the new device in, or that one device is broken, the technician goes out, brings in the new device, and the new device has only the tag name 00 or IP address 000, then it's automatically be downloaded his data, which is needing to be connected to the DCS to have the value to the DCS. So, and then it's working less than 1 minute, yes, again with the DCS. And so this is also a very big advantage when we work with this new technology, that it's, I would say, like home, yes. And you just connect, and in 1 minute it goes live. And so it's very easy to connect. It's very handleable, yes. And yes, that's the way. Also, don't be afraid. It's really easy to handle, and that's something where we are looking at, where we are convinced that this is the right technology for the near future.
Honestly, sounds easier than at home, because at home it never works.
Then you don't have a good network, yes.
Depends who's doing it.
Let me just ask one more question. I'm personally very interested in with which products Pepperl+Fuchs will support the Ethernet-APL topology.
Good,
Of course, our business,
got to
yes,
develop
our business is infrastructure. So everything which is required to interconnect field devices to your control system. So we are focusing firstly on switches, supporting different topologies. As you have learned this morning with the presentation from Andreas, there are so-called transfer topology and SPERT topology. And of course, we will support both topologies with dedicated products for different hazardous area use. The first product range we will present during EKIMA next year is the so-called rail field switch. A field switch basically which is used or will be hopefully used from the BASF in the future. A switch which has a standard 100 megabit backbone, and offering in a scalable way 8, 16 or 24 XIC2 spur ports for intrinsically safe Zone 2 Div2 application. That's the first series of products. And then later on, early 2022, we will start with a series which offers, again, installable in Zone 2 Div2 intrinsically safe spurs for Zone 0, Zone 1, respectively Div1.
Anything to add?
Unfortunately not.
Okay.
So,
since we already crashed our time, I would like to give you a chance. If there is any topic we haven't covered yet, just feel free. What else did we miss when talking about Ethernet-APL, which is important to say here in this round?
I would like to say one. The technology is more or less available, and we would like to invite customers, end users to use it. Because at the end of the day, the success of a new technology also depends on the usage. So therefore, the technology is available, use it, come to us, discuss with the Ethernet-APL team how to use it, because otherwise you will never be successful in your digital transformation in your company.
Right. Anything to add?
Yes, maybe a word to other suppliers where we traditionally not think about. We are thinking about process control, temperature, pressure, valves, whatever else. But I think, and I'm convinced that Ethernet-APL offers the possibility on areas where we don't have any clear view on it, or it's not yet used in a wide range because it's too time costly. So think about cameras. Why you should not use cameras, infrared cameras with Ethernet-APL? Using the same network, this is the most cost-effective impact on using cameras in hazardous area. You have to use a separate infrastructure. Now you have an infrastructure available which is there. It's already installed. So to add an infrared camera or a noise detector or whatever else is not very expensive and easy to go. So this only works if there are other suppliers using this technology to offer their product expertise for the process world. That's something which is, from my perspective, very important.
And as I said before, the time to start with such product developments, that's now, and not in a couple of years. And now it's for vendors, it's a good time to create USPs in their products, to add features that are today just not feasible because the interface isn't there. And it's now the time to start.
Right. Or let us just repeat the invitation. You said join this group of thinkers and
Absolutely.
developers for Ethernet-APL. So, sorry?
No, I just wanted to.
Just wanted to say yes. Well, then, thanks a lot, gentlemen. That was a real nice pleasure having you here and discussing about Ethernet-APL and the opportunities this technology offers for the future. And if you missed anything, no problem at all. Maybe you just switched in a little later. Just go to our online summit webpage, and then later you will find this round of discussion there as well. And of course, you can ask questions then. First of all, you see we got everything covered. We got the keynotes, we got the live lounges, and of course our networking lounge, the talk of experts. And as I said, if you have any questions for the aftermath, no worries at all. Just click on the chat button and you can ask the questions and we'll pass them on to our experts. So thanks a lot for watching, and we'll be back with our second session today at 2:30 p.m. German time with Ethernet-APL. Take care.